Jonathan here, and today I wanted to show you how to do sensitivity testing on SWS geothermal platform. So starting at the SWS geothermal platform homepage here, we can go to the GeoFires page. And let's say that we're interested in doing sensitivity testing on electricity sale price on the Fervo Cape Station 400 megawatt production example. So I can select that example here, press Run GeoFires Example, and then I will get my parameters and case report. So looking at this, we can see that we have an electricity break-even price of 2.78 cents per kilowatt hour. And then we also have some economic parameters, including net present value of approximately $4.5 billion, internal rate of return of approximately 44%, project MOIC, which is multiple on invested capital of 6.26, and a couple of other metrics here too. So looking at the parameters, we can see if we scroll down here a bit that we have a starting electricity sale price of 0.15, and that is the units for that is USD per kilowatt hour, so this is equivalent to 15 cents per kilowatt hour. One way that you can edit these parameters is in this text format, which is the same text format that you would use with the GeoFires open source package on, say, your local machine. So this is the same text file that you could copy and paste from your existing Python code that's using GeoFires and its equivalent. You can also, on SWS GTP, use the parameters editor. And the editor is a GUI version that is synchronized to what you have input into the text here. So, for example, if we look at the text here, we have a reservoir depth of 8,500 feet, and let's just change that to 8,501 feet. And then if we look in our parameters editor here, the change is reflected and we can see 8,501. So these two are synchronized, they're equivalent, and you can choose which way that you prefer to edit parameters given your context and particular needs. So if we look at the electricity sale price in the economics section of the editor, we can see the value that we saw in the text of 0.15, and the editor will also tell you the units for the value, or the default units if you don't override. So we can see that this is 0.15 USD per kilowatt hour. So let's say that I'm interested in what if Fervo was actually just getting 10 cents per kilowatt hour. So I can change that value here, scroll down, press Run GeoFires. Then my case report has rerun. And if I check the economic parameters, we can see that the net present value and the IRR, internal rate of return, have fallen quite a bit. If we recall, it was approximately $4.5 billion. Now it is around $2.9 billion, and the rate was about 44%, and now it's about 30%. So predictably, decreasing your electricity sale price will negatively impact these economic factors. We can also see that our electricity break-even price actually is unaffected. And this is an important distinction because the electricity break-even price is the price at which the project achieves zero NPV. So this value is not affected by the sale price that you're actually getting. It is a hypothetical sale price at which you're just making your money back. And it is separate from whether you're getting an actual return on that investment. We can also go and take a look at the electricity escalation rate. So this default value is approximately based on inflation for a 15 cent per kilowatt hour sale price. So let's say that we want to assume 2% inflation, or approximately 2% inflation. We could change this value to 0.0 0.02, and that represents roughly 2% inflation of a 10% starting price. And another thing that we can do with the editor is put in a comment so that we remember where this value came from. So I'm going to put a comment here that says approximately 2% inflation. And then once that's in there, I can go and press Run GeoFires. And we can look again, and we see that decreasing that rate has had a moderate impact on our rate of return. It's a little bit lower. And yeah, those are two ways that this is one way that you can do your own manual sensitivity testing on with GeoFires by manually editing the parameters, rerunning the cases, and then going and manually inspecting the results. But let's say that we want to be a little more systematic about this, or we want to test a range of values that's impractical to do by hand here. So in that case, we can go and press the Run Monte Carlo button here. And as the title text here says, this will let us run a Monte Carlo simulation with the same parameters that we have here in a separate tab. So we'll click that. And so here we are on our Monte Carlo view. In the left-hand column, we have parameters, just like in the GeoFires view. But they are slightly different because they are parameters for GeoFires plus the Monte Carlo simulation. So we have a slightly different editor, and we have some more parameters to choose from. So we can scroll, and we see those are the same as we had in the editor. And then we've also got these buttons here next to each parameter that if you hover over them, they say use simulation parameter as Monte Carlo input. So we want to test the sensitivity of starting electricity sale price. So we do want to use this as a Monte Carlo input. So we'll click this bell curve button, and that'll take us to our Monte Carlo settings section. And we have starting electricity sale price as a Monte Carlo input parameter. By default, you will get a setting with a normal distribution, a mean of the parameter value that you had input from GeoFires originally, and then a standard deviation that is 10% of that mean. So 0.1 and then 0.01 is 10%. But let's say in this case we actually want to test a uniform distribution of values. In that case, we would go to this dropdown and we can select uniform. And then our arguments for uniform are the low and the high value. And let's say in this case that we want to look at our sensitivity to electricity sale price from 8 cents up to, let's say, 20 cents. So that's 8 cents to 20 cents. And let's say that we also want to test our sensitivity to the escalation rate at the same time. So I can go back up to my parameters, find electricity escalation rate per year, press our Add Monte Carlo input parameter button there, and we get the normal distribution for that. And we'll be fine with the normal distribution, the default setting for this particular example, so we'll just leave that. Then we also want to choose a number of iterations that is going to have some level of statistical significance. So for now, I'll put in 100. If you're doing a more rigorous statistical analysis, you may want to do more than that, but 100 will be good for this particular demonstration. And then we also can choose the outputs that we're most interested in from the Monte Carlo simulation. And in this case, we know that electricity break-even price is going to be unaffected, so we're less interested in that. We know that average net electricity production is not going to be affected by the sale price, so we're also less interested in that. Same with the production temperature. And so we're interested in NPV and internal rate of return, IRR. And let's say we also also want to look at MOIC, multiple on invested capital, which is also often used synonymously with ROI. So if we step back, we can see here's our GeoFires parameters that were originally from Fervo Cape Station 3, and then our Monte Carlo input parameters with our number of iterations and our Monte Carlo inputs, and then our outputs, and that all looks good. So we'll go and run our Monte Carlo simulation. So now our simulation is running, and because we are running 100 instances of GeoFires with the different Monte Carlo parameter settings, this will take a little bit of time. So we will cut the video and come back when the iterations have completed. All right, so we are back about a minute later here, and our Monte Carlo simulation has completed all 100 iterations. And we have two types of results that we get for our Monte Carlo simulation. The first is our statistics. And for each output of GeoFires, or if you're running for this for HIP-RA, you would see each output for HIP-RA. You will get a median value, your average with your standard deviation, and your minimum and maximum values. So across all 100 iterations of the Monte Carlo simulation, this is what the median value for project NPV was, the average and standard deviation, the minimum and maximum. And then you also have a histogram as well. At the top, we'll see our outputs that we specifically designated earlier, so NPV, IRR, MOIC. But then if we keep scrolling, there you will also automatically see every other output as well. And so we have our summary of results, economic parameters, engineering parameters, and so on. If the value did not change across Monte Carlo iterations, instead of seeing the histogram and the statistics, you'll just see that value that was the same. So this is an easy way to see what outputs were actually affected by varying our inputs, which is another lens or another perspective on what your scenario is actually sensitive to. So yeah, we can see that there's some economic parameters that were affected, but many of the other parameters are not. And that's expected, of course, because the sale price is an economic parameter and not an engineering parameter. And also go over to the sensitivity tab and look at the sensitivity between any of our inputs and any of the outputs. So if we are interested in the effect of starting electricity sale price on our internal rate of return, we can go and select that here, and then we can press Analyze. And that'll take a moment to load. And once it does, we get this graph with starting electricity sale price on the x-axis and IRR on the y-axis. And we can see, fairly unsurprisingly, that there is a linear relationship between the starting electricity sale price and the internal rate of return. We could also take a look at that for NPV. And likewise, as we might expect, there is a relatively linear relationship. At the lower end, with an electricity sale price around 8 cents, we've got just under $2 billion. And then on the higher end at 20 cents, just around $6 billion. So we can do that for electricity sale price. And our other input was electricity escalation rate per year. So let's take a look at that. And we can see here that electricity escalation rate had a much weaker or possibly no effect on the net present value. And that's because the relative escalation is less significant than the starting value that you're actually getting as a baseline and building on. So if we go back to our starting electricity sale price, and let's say that we want to look at MOIC, again, we continue to see this linear relationship, and there are the wobbles, I will note, would be where it deviates from being purely linear, are because on each iteration we've selected a value for electricity sale price, which would alter that from the purely linear relationship that we would see if it was just starting electricity sale price. So using the sensitivity analysis, we can also look at the individual data points that for each iteration. So for example, if I wanted to see which scenario or which iteration had the maximum MOIC, the maximum ROI, that would be this one here. And when I hover, I can see that the two values, 0.2 for electricity price and MOIC 7.51. And then if I click it, as I just did, we can also see the specific input for that iteration. We'll wrap up our video. Hope you found this useful for getting started running your own sensitivity analysis, and we'll see you in the next one.